Hello, in this video, we are solving 8-point DIT-FFT radix 2 example. Let's start. Example is find DFT of following using DIT-FFT algorithm and x of n is 1, 2, 1, 2, 0, 2, 1, 2. First, this is a sample for which we want to find a DFT. DIT-FFT algorithm. There are 8 samples in this sequence. That means we have to use 8-point DIT-FFT algorithm. First, we should understand its indexing. This first sample indexed as a x of 0, x of 1, x of 2, x of 3, 4, 5, 6 and 7. So these samples indexed as a x of 0 to x of 7. Now let's start our DIT-FFT 8-point algorithm. First step, for 8 point, you have to draw 8 horizontal lines. Now, this 8-point DFT has a 3 stage of decimation. 8-point DFT, then we are decimating it to the 2 4-point DFT, and then it again decimated into the 4 2-point DFT. So first stage of decimation is 8-point DFT. For that, to draw a butterfly diagram or signal flow diagram, we are making or marking these dots so that it will be easy for us to draw a butterfly. Then second stage for 4-point DFT and third stage for 2-point DFT. Now left input or left part is time domain. Here we have to input our sequence, and right part is frequency domain. Here we will get our output, that is DFT, 8-point DFT. So our algorithm is DIT, that is decimation in time. So here there is a decimation. But in frequency domain, all the samples we have to write in a continuous order. X of 0, X of 1, 2, 3, 4, 5, 6, 7, like this. Now in time domain, there is a decimation. So we are decimating. Principle is we are dividing each DFT into the half. And how we are dividing half? We are separating even samples and odd sample. So first we are writing all the even samples. Just check the sequence. Even samples are x of 0, x of 2, x of 4 and x of 6. Now just check it order. Here x of 0, and instead of x of 2 and x of 4 we are swapping this positions, and then x of 6. Now why we are swapping? There is a principle. Just go through it to the previous video so that you can understand. But remember, this middle two we have to swap. Similarly, odd sample x of 1, x of 3, x of 5 and x of 7. Here also middle samples sequence we are swapping. After x of 1, x of 3, x of 5 we are swapping it. The position of x of 5 first and then x of 3 first and then x of 7. Just remember, in odd samples also we are swapping middle 2, and even samples also we are swapping middle 2. So make sure your sequence should be like this. Now we will start to draw a butterfly. We'll start from right side, 8-point DFT. First we will divide this all 8 lines into the half. Upper 4, lower 4. Now first line of this upper and first line of this lower we are using to draw our first butterfly. Each butterfly at the base it has a -1 and at the start W8 0. Then second butterfly, second line of this upper half, second line of this lower half. At the base -1 and here W8, now 0 is there, here 1. Then third butterfly, third line, fourth butterfly. Like this, at the each base we have -1 and before that butterfly W8 0, 1, 2, 3. Why there is 8? Because it is 8-point DFT. Now we'll write the values. We already know how to find this value. Please refer previous video for the values. Now next point is we have divided this 8-point DFT into two 4-point DFT. This is the first 4-point DFT and this is the second 4-point DFT. So first we'll decimate this 4-point DFT into, and we'll solve first this 4-point DFT. We'll divide it into half. First line of this upper half and first line of this lower half. Draw butterfly at the base -1 and here 4-point DFT, that's why W 4 and 0. Then second butterfly W 4 1. So upper 4-point DFT we have completed. Now lower 4-point DFT. Divide this into half. Okay, these values are 1 and -j. Now divide this into half. First line of this upper, first line of this lower. Draw butterfly. Similarly, second line of this upper and second line of this lower. Draw butterfly. Here W 4 because it is 4-point DFT. W 4 0 and 1. Write the values 1 and -j. Now last, here we'll draw 2-point DFT. Only two lines are there. So first butterfly, second butterfly, third butterfly and fourth butterfly. At this point we have completed our 8-point DIT-FFT algorithm signal flow diagram. Now let's start to solve our example. What is our x of n? X of n is this one. Now we have to input these samples. So check the sequence. First x of 0, then it is x of 4. X of 4 is 0. So x of 4, then x of 2 is 1. X of 6 is 1. So here it will be 1. Then x of 1, x of 5, x of 3 and x of 7. So we have to make sure right sample indexing we are entering. Once it is done, we'll use this butterfly diagram to solve our example. So first, this arrow, it is a multiplier and this dot, it is an adder. So first sample, here it has two input, this one and this one. So this one will directly here plus this second input is 0 multiply with this one. So it is 0. So 1 plus 0 is 1. Then here two inputs, this one and this one. This one is 1 and this 0 get multiplied with -1. This 1 plus 0. So it is 1. Here this 1 and 1 get multiplied. This value is 1. So 1 into 1, that is 1. So 1 plus 1 is 2. Here 1 and this 1 will get multiplied with 1. Again it will get multiplied with the -1. So this 1 plus -1, that is 0. Here 2 plus 2, 4. 2 and 2 into -1. That's a 2 minus 2, 0. Here 2 plus 2, 4. 2 minus 2, 0. Now we have to carry these values to the input of these 4-point DFTs. So here nothing is there. So directly we'll take this value. Here 0 multiply with 1. 0 multiply with -j. So it should be 0. If there is some non-zero value, that will multiply with -j and it will come here in the form of j. Complex value. 4, 0, 4. Then here again 0 multiply with -j. That's why here 0. Now we'll calculate the output. It has a two inputs, this one and this one. So 1 plus 2, 3. Here 1 plus 0, 1. 1 plus 2 into -1. So 1 minus 2 is -1. Like this, we'll calculate all the outputs. Now we'll carry these values to the input of next stage. That is 3, 1, -1, 1, 8. Now this 0 get multiplied with this value. But any value multiply with 0, it will come 0. If there is some non-zero value, here you will get complex value. because that value will get multiplied with this 1 upon root 2 minus j 1 upon root 2. So here you will get complex value. Here also 0, 0. Now we'll calculate the output. It has two inputs, this one and this one. That is 3 plus 8, 11. 1 plus 0, 1. Minus 1 plus 0. Like this. Now here, check it. 3 and this 8 will get multiplied with minus 1. So 3 minus 8 is minus 5. Similarly, you can calculate the other values. So this is our DFT. This is our answer, 8-point DFT. So our x of 0 is 11, 1, minus 1, then 1, minus 5, 1, minus 1, 1. So this is our answer. Remember, at the left hand side, there is a time domain. So there is a decimation, and time domain, all x are represented in a small letter. In a right side, there is a DFT, frequency domain, all x are represented by capital letter. It indicates it is a frequency domain. So this is a way how you can find 8-point DIT-FFT algorithm to find the DFT. Thank you.